Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on letter combinations of a phone number. So we'll be given digits and we have to find all the possible string combinations that we can form from the available numbers. Like for 2 we can have ABC and for 6 we can have MN0. So let's jump into the problem statement, understand it and start solving. By the way, we have reached 60th problem out of 75. So we are very close to making it 75 out of 75. Okay. Last time we solved the container with most water. You can find it in the list. Let's start with letter combinations of a phone number. Okay. Given a string containing digits from 2 to 9. Okay. Written all possible letter combinations that the number could represent, return the answer in any order. Okay, a mapping of digits to letter just like the on the telephone buttons is given below. Note that 1 does not map to any letter. Okay, so for 2 3 we are given two digits 2 and 3. What can be formed? For 2 it can be A, from 3 it can be D, so AD is possible, then AE, then AF. Similarly, then BD, BE, BF, then CD, CE, CF. Okay, so it's a very simple problem actually, and we have solved a lot of problems on backtracking and recursions as of now in the series, so it will be very easier to understand as well. So we'll use the same approach here also. We'll firstly create a map to store these values for the mapping, and then we'll use backtracking to go for all the combinations, where will we choose that for 2 we'll fetch all the characters, that is ABC, then we'll pick the first one, then we'll go with the next one, that is D, then we backtrack and remove D, so next path could be AE, we backtrack and remove E, then AF, we backtrack, remove F, then once we have removed all the D, E, F, we remove A as well and start with B, right? So we have already done these kind of solutions in the series earlier as well, so it wouldn't be something new. So with this, let's start coding. Okay, firstly we need a map. We need a map to store the mapping of each digit to its corresponding letters, right? Corresponding letters. Okay, so we can make a map private static. We'll make it static so that we can fill it in the beginning. Map, what type of map? We'll have character, so character, and they'll be mapped with string. Okay, so for since the input 2 3 is coming as a string, 2 is a character for us and 2 will be mapped with ABC, right? So we can call it digit to letters is equal to new hash map. Simple, right? Now similarly we'll use the static block to initialize all the values. So static initialization block to populate the map. So we can say static. If you are unaware of how static blocks work, there's a video on my channel already explaining about the static keyword and how it is used across its usages, so you can go and check that video. Digit to letters dot put. Okay, we'll enter the first value. So key is 2. For 2 the value is ABC, right? Similarly, let's copy it because we have to do it multiple times. Paste, 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 paste. Oops, paste and paste. We did something wrong somewhere. We have by mistakenly run it, but that's okay, we'll come to it when we come to it. So let's make the changes. 3 4 5 6 7 8 and 9. Okay, we actually came exact. So there will be DEF, then we have GHI, JKL, MNO PQRS TUV WXYZ. Okay, so this is done. After this, actually, since we are making them static, we don't want them inside this method. Actually, that's my mistake. Let me pull them out. Okay, let's take them inside the main class. Okay, like this. Let's give some indentation. How can we give it? Shift tab, right? Okay, now this is done. We have created a map. We have done this mapping, which was not already given to us, so we did it from our end. This is our main method where we have to return the answer in the string format, and we are given the digits in the string format as well. So we have to return list of string. Okay, so let's start. Let's create our result. So we can say result list of string result is equal to new array list. Okay, now we'll have our base case where, like given in the second example, if the input string is null or blank, we return the same, that is null or 0. So base case, if digits is equal to null or digits dot length is equal to 0. In this case, we'll return the blank result, right? Since result is already blank, we'll return it. Now, since we want to form all the combinations, like we pick 1 from the first character and D from the second one, we'll use a string builder to form any combination, because on the builder we can concatenate the next value. Strings are immutables, we cannot make changes with the strings, but with string builders we can make changes, right? So let's string builder to build the current combination. Okay, so that when we have AD is the current combination, we added it to the result list, we remove D, we move to AE, and in each iteration we add them to the list. That we'll be using during the backtracking. So we can say during backtracking. Okay, so string builder current combination is equal to new string builder. Okay, with this we can start with our backtrack. So we'll call our backtrack method, which will actually be solving this problem now. And after this we'll simply return the result. So we want to pass these values to the backtrack. So let's create a separate recursive method to help us solve this problem. Okay, so we can say recursive backtracking method, right, to generate all the combinations, generate the letter combinations. Okay, you can say private void backtrack. What all do we need? We first need our current combination, that is string builder, since this will be called recursively combination. We need our input string, that is digits, so we can say string digits. We need the index so that we know in each passing, because we'll be using the index to fetch the digits, right? Or let's say the character at the exact digit from the index. So we can say or for example 2 and 3 is passed and we have the index 0, so we'll pick 2. At index 1 we'll pick 3, right? So we need some kind of index. We can say int index. What else we need? Do we need anything else? No, right? So we'll, in the end we'll have a result. Okay, that's it. So from here we'll simply call these same attributes, current combination, next is digits, starting index will be 0 and result is result. Okay, let's come to the, let me expand this for everyone. Okay, and let me close this down a little. Okay, let's start here. Now we want to perform the backtracking and we are going to perform it from the starting index. So starting index is 0, given digits is 2 3 if we consider this example. So let's have a base case, right? Because if 2 3 is the overall length, the overall length of the formed strings can also be only 2. So once our index reaches the end of the length, that means we have at least one combination formed and we can add it as part of the list, right? So we can say base case, if we have processed all digits, add the current combination to the list, current combination to the result list. Okay, how do we check that? If index is equal to digits dot length, right? If this happens, we can add the current combination to the result dot add current combination dot, we have to convert it to string, to string, because that is in string builder format. Okay, to string, it's done, will return. Otherwise, so that's the also the breaking condition for all the backtracking methods when it will be called recursively. Otherwise, we'll get the current digit, that is for the first case for 2 will be our current digit, right? We can say get the current current digit and its corresponding letters. So for 2, so we have to fetch 2 and ABC. Where can we get the 2 from? We can get char current digit. We can fetch the 2 from the digits dot caret index, right? We got 2. Now for 2 we want to fetch the ABC that we have stored here in as part of the map. So let's fetch it from the map. So how do we fetch it from the map? We need it as part of the string. So string letters is equal to what's the map name? Digit. What's the map name? Digit to letters. Okay, it's digit to letters dot get, and then we pass the current digit, right? So we got the current digit, which in our first case is 2. We got the current set of letters corresponding to the digit, that is ABC. Okay, so one by one we want to traverse through them, and for each combination we want to pick it once, that is A, and then call the same method recursively. So we can say iterate through each letter and explore different combinations. Okay, so for char letter from letters dot to character array. Okay, we got our first letter. We'll choose the current letter, and current combination is blank, right? We have not added anything to the current combination, so we can say current combination right now is blank. So we'll concatenate this as part of the current combination. So we can say or choose the current letter. Okay, so we'll say current combination, and let's append will add it into the same string, the next character. Okay, now our first letter was A, so A got appended to the string was blank, it became A. Okay, now we have explored A from the first digit, first available characters for the first digit, right? So now we would want to explore the next possibilities from the second digit, right? So we can say explore further with the next digit. So we'll call the same method again, backtrack. We'll pass the same current combination, which is now a current combination. Digits will remain same, digits array. Index will get increased, index plus 1, and result will remain same. Okay, that's it. Once this is done, so we are calling the backtrack method again. This will be called again. Current combination is now a, digits is same, index is 1. We do, is index equal to digits dot length? No, digits length is 2, right? So it comes here, current digit would be digits dot caret index 1. So now we will get 3 letters digits to character array. Will get ABC. We had ABC earlier, now we will get D, E, F, right? Now similarly we will process letter. We'll get the first letter, that is D, and we'll append it in the current combination. So current combination will become AD. We'll call the backtrack method again. Again we'll come to this part. Now index would have increased to 2. Index is equal to digits dot length. Yes, that is correct. So current combination will be added to the result. So now the result will have first combination, that is AD. From here we return back. It return back to the last formation where we had AD from this backtrack. Okay, the last formation of AD. So we want to remove D part here and continuously call this method again. So let's remove the D from here, right? So that's why backtracking. So we can say backtrack, remove the last letter to explore other possibilities, right? So we can say current combination dot delete character, delete caret current combination dot length 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 -1. Okay, so now from the current combination we removed D. So current combination again became only A. Okay, so since we are already as part of the inner loop for DEF, we get the next character in the loop, that is E. E is now attached to current combination, and current combination becomes AE, right? Now backtrack method is called again. Index value is 2 and index is equal to digits dot length. Yes, so to the result we add the current combination, which is AE. So AE gets added to the result list. Then again this backtrack is complete, this E gets removed, we get the next character F, and AF is added. Now this backtrack is over, and overall this for loop is done. So this method gets closed. It reaches back to the last backtrack, which was called from A, and A gets removed from the current combination, and we start the whole journey with B, and next will be BD, BE, BF, then CD, CE, CF, right? This way the overall backtracking and the solution would work. It's a very simple solution if you go through it and have understood it by now, and we have already solved a lot of problem on backtrack. You always know we go for the next combination, we remove the last path that we covered, and we retrace the same thing. Okay, so for any backtracking you need 3 things. One is recursively calling it. Okay, second is the break condition, and third is removing the last combination to keep changing the paths. That's all. Yeah, let's run it and test. Have we missed anything? We are returning the result, that is okay. Oh, something somewhere is not right. String builder, string. Okay, let's see. Current combination, what's wrong with current combination? CURRENT okay, let's say okay, it's working. Let's submit and check, and we have chosen quite efficient approach. Okay, great. Beats 80.31% of the users. I was actually expecting that it might be better than this one as well. But great. So a lot of people followed the same approach. Let's resubmit it and see. Oh, beats 100. Okay. Sometimes there can be some caching as well, right? So that's it, guys. That's all from today's video. If you have anything, please let me know in the comment section. And in the end, please like, share, and subscribe. Thank you.